Hi, my name is Peyton Denning,
My name is Evan Nunez.
and today we're going to be talking about our engineering book, Chapter 1.
The sections are divided into 6 parts, and we will be presenting those parts.
So, Section 1.1, an engineering career. So this chapter is pretty much, this section is pretty much all about finding what you want to do with your life, and finding what career is right for you. If you're interested in joining the technological field, or exploring careers in engineering, they really suggest that you look into it. There are over 380 colleges offering close to 1,900 engineering programs in the state, in the United States and in Canada. So look around, ask people what you want to do, ask professionals what they do for a living, and see if you want to do that. You can be as specific as you want, wanting mechanical engineering, just specify in what you want to do with your life, and find the career that is right for you. So our first sidebar story is about Dean A. Hawkins. This is mine. He had a Bachelor of Science in Aerospace Engineering and a major in Aeronautical Engineering at the University of Washington. These sidebar stories are stories about recent graduates with engineering degrees and them entering their engineering world and career. He got a job working at Boeing on commercial plane divisions in Seattle. He conducts aerodynamic tests in wind tunnels. He's done over 787 wind tunnel tests. He's on the leading edge of commercial aircraft development in the world. And here we have a wind tunnel similar to the one he works with. And here's the construct of one. He's a very interesting guy, and he is on the aeronautical space. The second sidebar story is about Dr. Julie Friend. She studied chemical engineering in French and had a PhD in chemical engineering. She studied abroad in Switzerland and was also in her school band. She's very involved. She's the senior research engineer at DuPont in Wilmington, Delaware, which has over 60,000 employees, over 70 countries. She works on research and development, and her goal is to discover a product that is both chemically sound and cost efficient. She is fond of the way engineering has taken her in her life and all the places that engineering will take people in their lives. It's very open to people. And I'll pass on to Osmani.
Thank you. As we saw, Dr. Julia Friend was an engineer. And as an engineer, you work in a technology team. So my section 1.2 is about the technology team. So Thomas Edison, back in 1876, he gathered a group of 15 men, like his team, and they went to this place called Menlo Park. And there they just worked on inventions, they experimented, they developed, and all that. And then within the next 10 years, they acquired over 400 patents on those inventions and all that. And so back in 1876, it was quite unusual to work in a team. Usually it was one person. One person did everything. They researched, they developed all by themselves. And so it's very different today because technology has advanced, and we need a team to be able to do all these different tasks and know all these different things. And so it requires unique skills of different members in the team to work together. So the first part of this team is the scientist. So the scientist is in charge of acquiring knowledge, researching, just finding out more about the subject. And they work well with engineers because that's a source of their knowledge. They can see what the engineers are doing and then acquire more knowledge that way. And of course they find knowledge by using the scientific method, observe, ask questions, make a hypothesis, test that hypothesis, and then get your results, analyze your results, and acquire the knowledge. And usually they have open and curious mind. All right, next part is the engineer. The engineer applies their knowledge of math and science to find solutions. So they they usually already know, of course, a lot of science and math, and they have to, identify the problem, find the solutions, and they're the ones who present the plan to the team, what they're gonna do. And then the next is the technologist or technician. They're the ones who, they see the idea right from the engineers, and then they make it happen pretty much. So, communication, they talk with all the members in the team, and, make sure everyone knows what's going on. And usually, drafting, estimating, model building, and troubleshooting. Skilled tradesperson or craftsperson. So they pretty much build all the stuff, if they need a part, they're the ones who go and make that part so then the team can use it. And, like welders, carpenters, plumbers. And okay, my first sidebar story, it's about Donna Faust. She had a Bachelor's of Science in Chemical Engineering and an MBA in Marketing. She was the senior marketing manager of Conagra Foods. So she and her team, they worked together to create new food products and stuff like that. And she was also a member of the Society of Women Engineers. And because of that, that led her to many opportunities and becoming a chemical engineer and being manager of Conagra Foods. And so her advice was to talk to all the students in the different areas, right? Different areas of careers, because you can learn a lot from other fields. And then let's see here, David Schalberg is the other sidebar story. He also had a Bachelor's of Science in Chemical Engineering and an MBA in Finance. So he was the senior consultant and project manager of Black & Veatch. He had over like 8,000 employees in his business, and they're very diverse, many different people, different jobs and all that. And 90% of his work was interacting with others, going and talking to people, talking to other managers, other companies and all that. And the engineering degree has many different career opportunities, so it's a good way to go. Hand it off to Jason.
Alright, so section 1.3 is the engineering profession. So most people think when they hear engineering is working inside cubicles and just solving mathematical equations. That is wrong. Engineers actually work in a team and try to solve common problems so they try to make life easier. And engineering is really fun and challenging in many ways. I did the 5th sidebar story. It's about Mark Lamb. He got a bachelor's in civil engineering, and when he finished his 4-year degree, he joined the Snyder and Associates, which is located in Iowa. He's a certified professional in erosion and sediment control. And as an undergraduate, he was in many fields of engineering. He joined the American Society of Civil Engineers, the Steel Bridge Team, and Civil Engineering Supreme Committee. When he talked about this in his story, he said that try to get inside as many clubs as you can, so you learn how to become an engineer and feel how it feels to become an engineer. So Edgar Snyder. 6th sidebar story was a story about Morgan Hobson. And she earned a bachelor's in industrial engineering, and she minored in business, and she's going for her MBA in business as well. She got employed at a big company, John Deere, at Iowa, and she designs the manufacturing sequence of Lancer products. While a student, she was also in Central Committee of Engineering, and she was like the head of it, so she was responsible for the website, fundraising, and advertising. 7th sidebar story was about Sheila Rajendran. She earned a bachelor's in mechanical engineering, and she was a senior associate in Caterpillar Global Engineering Development, and that's also a big brand out there, they're a big company. And she's a performance analyst inside that company, so that means that she does engine testing and sees how it could become better, and she also develops some of the engines. She plans to pursue her master's degree, and she also wants to become a manager in the Caterpillar industry. I'll pass this off to Chris.
Hello. Hello, my name is Christopher Mercado. I did section 1.4, and first, by starting off, section 1.4 talks about 11 different types of engineering functions, and those 11 types of engineering functions is what I'm going to go over today, and are the ones that are listed right here. The picture right here is has all 11 of those, and it says this over here on the left side is more theoretical, and the ones over here are more applied engineering ones. But all of them involve engineering, but only some of them involve engineering technology. So the research engineer. To have some of the qualities for a research engineer include perceptiveness, patience, and self-confidence. Most will get their master and doctor degrees to have a more intellectual abilities for the engineering process, and the research involves tests, failures, and testing again until you finally solve out what's the problem. Billions of dollars are actually spent each year on research in colleges, universities, private funding. So there's a lot of money that goes to all the research that they do for the engineering process. And the fastest growing research right now is nanotechnology. Development engineering. They attempt to produce functional devices, structures, processes. Building and testing models is how they attempt to produce these. Making models have been made much simpler these years, such as the 3D printing as we have here, or the actual virtual reality software like our computers in the back room. The first pacemaker was made in 1950 or the 1950s, and it was a big box. It was an external AC powered unit that sent pulses through an implanted wire to the heart. And actually, due to this development engineering that they developed, now it is just a little tiny thing that they put in your heart 13 years later, and makes people live a more easier life than carrying a big AC unit around. So, the design engineer. The models that the research engineers are passed on to these design engineers for converting into actual devices and structures in the human world. They rely on education and experience and have to keep always 4 things in mind when designing the products: cost to manufacture, ease of production, availability of materials, and the performance requirements. Several designs and redesigns will happen before the product is brought to the public. And so just like a phone or even a building, they'll always go over and keep redesigning until it finally has the right stability and power to help humans out rather than just for a little bit for a longer time. Production and testing engineering. So once the device has been approved for the public, production and testing facilities are ready for mass production. The first step in production is to devise a schedule that will efficiently coordinate materials and personnel, such as the engineers. So the production engineer is also responsible for such tasks as ordering raw materials at the needed times, setting up the assembly line, and handling and shipping the finished products. The qualities for production and testing engineers are the knowledge of design, economics, and psychology. Test engineers work from the time the product is finished until it is no longer manufactured. Testing is usually done through 3D models and analysis software, and they're usually responsible for the quality control. Knowledge of statistics is beneficial for being a test engineer as well. So we have the construction engineer next. The construction engineering have a process of estimating material, labor, and overhead costs. The construction engineer is responsible for coordinating the project. Construction engineers need a strong background in engineering fundamentals, on-the-job experience, and an understanding of labor relations. They also must be familiar with the LEED, which is an International Building Certification System. The LEED assesses building design for energy saving, improved indoor environmental controls, CO2 emissions reduction, water efficiency, and stewardship of resources. So, the next thing is called the operations. Oh yes, the operation engineer, which sometimes is called a plant engineer as well. They select sites for facilities and they specify the layout for all the needed places for the operation. And select the fixed equipment for the climate control, lighting, and communications. They're also responsible for maintenance and modifications as required within the building. Knowledge of basic engineering, industrial engineering principles, economics, and the law are prime requirements for their education. Sales engineer. Okay. And respectively, all engineers are involved in selling, because selling means convincing management that money should be allocated for development of particular concepts or expansions of the facilities. But what sales engineers actually do is find or create a market for the product to be sold. Excellent communication and teamwork skills are important to becoming a successful sales engineer. Some of the qualities for them are having an engineering background, obviously, sincere interest in people, because they'll be talking to a lot of people trying to sell the product, and a desire to be helpful. Sales engineers are also responsible for coordinating services and maintaining customer satisfaction. Management engineer. So they just make the decisions that will affect and involve thousands of people and millions of dollars, because they make the final calls to management. And some colleges actually now offer the opportunity to obtain an undergraduate engineering degree and a master's of business degree at the same time, with as little as just 1 year added onto your college plan. So that would, I guess, make you a manager. And the consulting engineer. Consulting engineers usually operate alone or in a partnership, furnishing specialized help for clients who request it. A sense of integrity and a knack for correct engineering judgment are primary necessities in consulting. A consulting engineer must also possess a professional engineering license before beginning practice. So know that. And the last one, the engineering teacher. An engineering teacher must possess an ability to communicate and abstract principles and engineering experiences in a manner students can understand, like us. And teachers must follow general guidelines, but are usually free to develop their own method of teaching. If you're interested in a teaching career in engineering or engineering technology, you should observe your teachers carefully when they teach as you pursue your degrees. And that's it. So. Oh. Alright, so I'm going to pass it on to section 1.5, Dylan and Irvin now.
So before we start, can I see a show of hands of anyone who might be interested in an engineering career? Okay, so we're here to talk to you about section 1.5, which talks about different types of engineering. For example, our first one, aerospace engineering, which consists of the study of motion and control of all types of vehicles, such as aircrafts, and sometimes those aircrafts can weigh up to even 1 million pounds. Second one is chemical engineering, which consists of the use of technology that utilizes chemical reactions to solve problems. And chemical engineering is used a lot to develop foods that are safe for us, foods that are healthier for us, and foods that taste good. The third one is civil engineering, which is one of the most common types of engineering, and that involves the development of infrastructure such as buildings, railways, roads, and also project management. Our fourth one is electrical computer engineer, part of our everyday life. And it involves telecommunications and networking, and it's growing every day, so we need a lot of people in that field. And now to finish off section 1.5.
Okay, so, the other two types of engineering are environmental engineering, and what they do is they combine soil sciences, chemistry, and biology to develop solutions to environmental problems, such as, pollution and different types of, just different things to make our earth better. Industrial engineers, they optimize industrial processes to make them more efficient and, eliminate factors such as time waste, wasting time and materials and money that don't generate, more value. Then we have mechanical engineers, which mechanical engineering is a very broad, it's a very broad division of engineering. It has a lot to do with, really physical types of engineering. It's really hands-on. And what they do is they work on industrial machines and like cars, different production lines, things like that. And so, yeah, that's the 7 types of engineering. So, conclusion, debate and any. So in section 1.6, the book kind of makes a conclusion of chapter 1. They touch down on all the possibilities that engineering can offer. They show us the types of engineering we can do, the engineering process and teams. They really emphasize the importance of education and how to push yourself to become a better learner and a better worker someday in the engineering field. They want you to keep up with technology that's being used in your field. Like, say, you're a biomedical engineer. They want you to keep up with the technology that's being created to help people and save their lives. Keep educating yourself. Even after you think you've gone to college, go back, get a business degree. Go back and get more masters in engineering. And as becoming an engineer, many challenges await you. So greet them and make them move forward.